Hello and welcome to another episode. I was working on my list of facts that aren't true when I got to the North Star is the brightest star. I already knew the answer, which I'll share with you soon, but then I started thinking, has the brightest star ever changed? I actually knew the answer. It has, and more than once. So after investigating, I realized this is enough material to do a standalone episode on. Enjoy. Okay. Here's the answer. Sirius is the brightest star you can see from Earth at night. It is nicknamed the Dog Star because it's part of the Canis Major constellation, literally big dog. And Sirius is really easy to find. For one, it's the brightest star in the night sky, but all you need to do is find Orion's belt and follow the line his belt makes from the top right to the bottom left and keep going. You've probably heard the phrase dog days of summer. That comes from the fact that Sirius, the dog star, rises to its highest point in the sky during summer in the northern hemisphere, which would be right about now. But Sirius hasn't always been the brightest star. 7,500 years ago, a star in the Milky Way went supernova. 6,500 years later, that light reached Earth. The star is 6,500 light years away from Earth. The year was 1054, and the date, funny enough, was the 4th of July. Today you cannot see the light from this explosion with the naked eye, but in 1054, the light was so intense that it shone significantly brighter than the planet Venus. It was the brightest star in the night sky by a long ways. In fact, Chinese astronomical records indicate the supernova was visible during the daytime for 23 consecutive days and visible at night to the naked eye for 462 nights. Today we can see what's left of the supernova, a so-called supernova remnant. It is known as the Crab Nebula, and to me, it looks like seaweed. Much of the glow comes from a spinning pulsar in the middle. A pulsar is a spinning neutron star. A neutron star is what's left after the core of certain gigantic stars collapse inward. The rest of the star is ejected and forms most of the stuff you can see right here. But this wasn't the brightest supernova humans have ever seen, and therefore it's not the only other thing that's been the brightest star you can see from Earth at night. That was almost certainly SN 1006. SN means supernova, and 1006 was the year. We think it occurred around May 1st. SN 1006 is about 500 light years farther than SN 1054 and the Crab Nebula, but was 4 times brighter. That is, as viewed from Earth, it appeared 4 times brighter. Brightness is measured on a scale called apparent magnitude. The sun is obviously the brightest thing we can see from Earth, and so it has the greatest apparent magnitude. The next brightest object is the full moon, followed by Venus. SN 1006 shone 16 times brighter than Venus in the year 1006 when we first saw it. Looking at its remnant today, scientists can't find evidence of a neutron star or evidence of a companion star. So now I have to tell you what I mean by that. Many stars in the universe have a companion star, and they orbit one another. One of those stars may become a white dwarf, which is a leftover core of a medium mass star like the sun, and those stars themselves don't go supernova. A white dwarf has incredibly concentrated gravity. They are super compressed, close to the size of the Earth, but they'll have a mass between 1/5 and 1.4 times that of the sun. Now, this doesn't necessarily change anything right away. The white dwarf and its companion star will continue orbiting each other, albeit with slightly different orbital mechanics. However, if the companion star begins to swell, the white dwarf will pull in material from it and form an accretion disk around itself. This accretion disk adds mass to the white dwarf. To make things simple, eventually, the mass of the star becomes greater than the internal quantum forces preventing it from collapsing in on itself due to gravity. Once this happens, the white dwarf collapses until the opposite happens, and quantum forces greatly exceed the force of gravity, and the white dwarf explodes. This is called a Type 1a supernova. Now, I tell you all of that just to tell you that scientists can't find any evidence that that's what happened with SN 1006. This has led astronomers to suspect that SN 1006 was perhaps the result of two white dwarf stars colliding with each other, triggering a unique type of 1A supernova. So, what we have here is two stars that we know for sure for a few days, well, actually nights, were the brightest star you can see from Earth. Throughout the rest of human history, Sirius has always been that brightest star. But what we want to know is, what is next? What will be the next visible supernova? Well, it'll probably be this, which is Eta Carinae. Eta Carinae is very similar in distance to the other two. It's 7,500 light years away. Eta Carinae is the most capricious object in the sky. At times, it has been the second brightest star in the sky. That was in the 1800s. But at other times, it has been totally invisible to the naked eye. It is currently, its current brightness is about that of the average star. So you can see it with the naked eye, but it doesn't stand out at all. But Eta Carinae is a ticking time bomb. Eta Carinae is actually another binary star system. Both of the stars that make up Eta Carinae are extremely massive white-blue stars, and they are named Eta Carinae A and Eta Carinae B. A, the larger one, is the one that will one day explode. The mass of Eta Carinae A has been estimated at 100 to 120 times that of the Sun. When Eta Carinae finally goes supernova, it's very possible that it will be brighter than the full moon. That's it for this episode. Thanks for listening. Now it's Q&A time. What do you want to know? What about Betelgeuse? Yeah, so a few years ago, we thought that Betelgeuse was going to go supernova. Betelgeuse. It's not spelled like you think it is. It's spelled kind of funny. Now, you guys... Okay, so a few years ago, Betelgeuse, it shifted dramatically in its brightness, and so a lot of astronomers guessed that maybe it was getting ready to go supernova. Perhaps it was starting to collapse inward, and then maybe it would explode. Although I think that would happen so quickly that it wouldn't be observable over a period of days. But its brightness drastically changed. Now, what we think actually happened was... Oh yeah, this picture is actually showing it. What we think happened is some sort of really weird, kind of like a solar flare, like a coronal mass ejection. We think Betelgeuse basically threw up. It ejected a huge mass of material. And Betelgeuse, if you didn't know, I'll talk about this later. So it ejected a huge mass of material. Now, once that hot plasma got away from Betelgeuse, it cooled down, and so it basically created sort of a shadow, and that's what we think the dip in Betelgeuse was. For the record, Betelgeuse is, if that's the sun right there, then Betelgeuse is this one right here. So this is a really small picture, but Betelgeuse is hundreds and hundreds and hundreds of times bigger than the sun. If we put Betelgeuse in our solar system, its outer edges would go past Jupiter, I believe. It's huge. Betelgeuse, basically in layman's terms, farted back in 2019. That's pretty much You're not wrong. How reliable is NASA's public data when they've been lying about aliens? So we don't have any confirmed evidence that they're actually lying about aliens. We have a whistleblower, but the whistleblower didn't see anything that the whistleblower is reporting. The whistleblower is reporting that he's been told these things. Are there any stars we've lost sight of because they've died? Well, yeah, I mean, the ones I talked about in the podcast. So, SN 1006 was, I don't think we know if it was visible to the naked eye before it blew up or not. Well, if it was two white dwarfs, then it definitely wouldn't have been. But that we could see it, and then we couldn't see it anymore. So, yeah, that one. Now we can see it with telescopes, but you can only see around 5,000 stars from Earth with the naked eye. And then the star that formed the Crab Nebula, that was probably visible to the naked eye because it would have been it would have been a blue star, which are the most massive stars. And then it got even brighter, and then after the glow from the supernova was no longer visible, it's not visible to the naked eye. Another example would be so the word nova comes from Johannes Kepler. It literally, or not Johannes Kepler, sorry. Tycho Brahe, and everybody always tells me I'm pronouncing his name wrong, but I don't know how you're supposed to say it. I think he was Dutch. He got famous because he was the first person to sort of officially scientifically describe a new star, and that we know was a supernova too. I think it's literally called Tycho's star to this day. That doesn't look real. This looks like, when you do when people do those confetti 5Ks, that's what that looks like, right? But this is Tycho's star, and so he, when this happened, again, this was the 1500s, so people weren't even using telescopes at the time, but people could see all of a sudden there's this thing in the sky, and it wasn't the brightest star, but it was up there. So SN 1572, that means, oh, you guys can't see that. Oh no. So you'll just have to take my word for this. SN 1572 means it was a supernova observed in the year 1572, right? Now people thought maybe it was some sort of weird aberration that was occurring in the sky closer to Earth than the moon was. Tycho somehow figured out that couldn't be the case. I'm guessing he did it through parallax. So he sort of proved that it was it had to have been some sort of star. Oh, that's amazing. So this is just footage showing its expansion. So that's pretty cool. The crazy thing about these supernovas is they're expanding at millions and millions of miles per hour, but even if you watch them for 100 years, they don't change in size that much. That's how crazy huge the sizes we're dealing with are. So this one, I don't know if it's visible to the naked eye currently. What's its apparent magnitude? Peak apparent magnitude, -4. Okay, but what's its current apparent magnitude? Okay, so it looks like it actually probably is visible to the naked eye, because anything that's around magnitude 3 you can see, and weirdly, the smaller the number, including negatives, the brighter it is. Okay. Can I talk about the different types of nebulae? Well, sort of. Nebulae. Learn how to spell, you moron. So there are, well, in the MC universe, there are these, right? No, I'm just kidding. How do I say this? The classical, what people usually mean when they say nebula is a nebula is just dispersed stellar material that eventually has the potential to form stars. So a lot of nebulas are like stellar nurseries. The most famous one is the pillars of creation, right? So this is many light years across. And there are stars forming inside of it. But then there are what are called planetary nebula, or nebulae, whatever. And these are some of the most beautiful things out there. Let's open this in a new tab. So these are leftovers of, here's the Helix Nebula. Oh, you can't see it because of me. It's commonly called the God's Eye Nebula or whatever, or the Cat's Eye Nebula or whatever. So these form when stars like the sun, which don't go supernova, when their core collapses, they push all the outer layers away from them. So that is what planetary nebula are. Now that right there, that is Eta Carinae, so they shouldn't have that in there. And that's the Crab Nebula, that shouldn't be in there either. But that's what a planetary nebula is. The word nebula is kind of like, it's not a throwaway term, but it's overused. What am I going to talk about tonight? I might take a break tonight, actually. Am I debating today or working on the book? I don't know. I did the podcast. I don't know what I'm going to do with the rest of my day. What if I have a mole that looks like that? I don't know. Go and see a healthcare professional. Did I miss any questions? Looks like a microbe, craft body. Everybody was laughing at Ducray earlier. I don't know what she said, though. Do stars either go supernova or black hole, or is it both? Okay, so that's a really good question. So I was told that, I always thought that, so the supermassive stars, death of massive star. I was always told that the really massive stars always go supernova and then either form a black hole or a neutron star. Now, I was later told by some people that, well, actually, if it forms a black hole, there won't be a supernova because a black hole absorbs and destroys all information. So, and its gravity would suck in all the material from the outer layers of the star, and there would actually be no visible supernova. And I was like, that actually makes perfect sense. But when I was researching for this podcast, I got conflicting accounts of that. So what the data I'm seeing says that astronomers think some stars that form black holes do absorb all the stellar material around them, or not necessarily absorb them, but prevent a visible supernova from happening. Whereas other sources are telling me, no, the supernova will still happen, and a black hole will form. So I don't know entirely. Like that Eta Carinae star I talked about here, this star is absolutely enormous. It's over 100 times more massive than the sun. So that's going to form a significant black hole. Now, is the event horizon going to be so big that we don't see a supernova? Well, like literally all the sources I've looked at are telling us that it will form a visible supernova. So I don't know. Neil deGrasse Tyson needs to do an episode on Star Talk about it and have on Phil Plate? How do you say his last name? Plate, or Professor Nixie should go on Star Talk, so we can figure this out. Because I don't know. I've heard conflicting accounts, and it's a really good question. Am I putting these on Spotify? Yeah, I have like 20 something podcast episodes on Spotify. Just go to my link tree. You'll get a link to it. It's on Apple Podcasts too. It's on YouTube as well. Are there any theories of the origin of the universe or just Big Bang? So the Big Bang isn't really an origin of the universe idea. It's an idea of what did the universe start doing the moment the element of time became part of the fabric of our universe. Now, there were other ideas. Like there's a plasma theory. There's a steady state theory. I'm not sure if the one electron theory is, I don't think that's not like a Big Bang competitor, I don't think. But there have been other ideas, but none of them are, like the Big Bang made very specific predictions that came true. So there aren't any competing ideas that are very well backed up. We'll say it that way. How much does the universe expand? like what is physically expanding. So matter in the universe doesn't expand. I actually have a video about this on my TikTok. You'd have to go back a little ways though. I also have a video on my YouTube channel, and I think it's called Guest Cannot Comprehend an Expanding Universe, because I talked about it. Professor Nixie was there for that. We talked about this for a long time. So space itself expands, not the objects in the universe. They don't expand. Has a supernova ever hit Earth? It's possible that it happened many, many millions of years ago, billions of years ago. I think at one time there was there have been 5 mass extinctions on Earth, and there's a couple of them, like the really old ones, we don't really have the best idea of what happened, but we think that one of them could have been triggered by like a solar flare or something like that. Did a supernova trigger a mass extinction? I think Anton, what's his name? Anton Petrov something. Supernova caused this. Yeah, so if you guys don't know Anton Petrov.
Oh, look everyone.
He's got a really great YouTube channel. So I remember, I don't know if I watched this whole video or not, but there is an idea that one of the major extinctions was caused by a supernova. So watch Anton's video of it. He does really great work, because I don't remember the details. What kind of matter is nebula? It's well, a nebula isn't actually plasma. It's actually just pretty much hydrogen. Almost the entire thing is hydrogen. But because the nebula is so spread out, and what you're seeing here is a close-up of the part of the Horsehead Nebula, maybe, I think. I'm not exactly sure. But it's actually so spread out that it's not hot enough to be plasma. It's illuminated by the surrounding starlight. And a part of the illumination may actually be the material itself, but hydrogen will glow before it turns into a plasma, I think. I think it gets hot enough to glow before it turns into a plasma. What makes a star brighter? Proximity, type of fuel. Really, the only thing that makes a star brighter is its mass. Well, okay. So, really good question. We got to look at the Hertzsprung-Russell diagram. In general, stars spend the majority of their time in what's called a main sequence stage, where it's just a star doing nuclear fusion, right? So along those lines, can I make this smaller actually so everybody can see it? So in general, the only thing that makes a star brighter is its mass. The biggest stars compress their hydrogen the most and glow blue, and they're the hottest and brightest. Now, when stars evolve to different points in their life cycle, they can change. So for example, the sun, when it starts to do fusion in layers outside the very middle of the core, it's going to balloon into a giant. Now, it will get brighter because it will get physically bigger. It'll actually cool down. We can see it goes from, the sun is actually white, but they have it as yellow. But the sun will go from white to red in temperature. So it'll cool down, but it'll be physically so much bigger that it'll actually be brighter. Why don't galaxies have magnetic fields like the Earth does? Well, that's an interesting question. So in order to have, like stars have magnetic fields. So to have a magnetic field, you have to have, in the case of the Earth, we have moving, we have circulating ferric material. That is material that can conduct magnetism, right? Now for a star, it's because it's made of plasma. So the magnetic field of a star and the magnetic field of a planet like Jupiter comes from the fact that it has ionized material in it. So for a star, it's because there's, for Jupiter it's different because we have liquid metallic hydrogen. But for the star, because it's made of plasma, that means you have separation of positive and negative charge, and electricity and magnetism are actually the same force, electromagnetism. So if you have swirling plasma, if you have a circulating electrical material, it's a dumb way of saying it, but that will create a magnetic field. Just like, generators, all you're doing is spinning a magnet that creates an electric field. A spinning electric field will produce a magnetic field too. So a galaxy, the thing is with a galaxy is when you look at pictures of galaxies, it looks like if we look at this, it looks like an object, but a galaxy isn't really an object. It's hundreds of billions of stars that form a rotating disk because of mutual gravity. It's held together mostly by dark matter, but dark matter, regular matter, gravity is still the force holding it together. So, and what's weird is, it doesn't seem this way, but the gaps between the stars are actually enormous. It's many light years on average, or a few light years on average, I should say. So I don't know if you can see the magnetic field around. I don't know if all the collective magnetic fields of the stars creates a sort of magnetic field signature around the galaxy. That's a really interesting question. I have no idea. We can ask ChatGPT. Do galaxies have their own magnetic field? We'll ask ChatGPT 4. Yes, galaxies do indeed have their own magnetic fields. I'm learning. These magnetic fields are believed to be generated by a dynamo. I mean, this could all be complete garbage. I have no idea, but the motion of conductive plasma within the galaxy combined with the galaxy's is incredibly weak. I don't know. I mean, yeah, maybe. Why is there such an infuriating correlation between incorrectness and confidence? Because if you don't know better, you don't have any evidence that you're mistaken. I mean, it's actually kind of simple, and it's unfortunate, but it's just the way we are.